Now that you possess some general knowledge of how to use the scanner, it's time to take a look at specific most probable scenarios where you will be using Leo and Artec Studio in your work. We will start off by explaining how you can scan a dead body in a morgue and acquire the most accurate surface data of wounds and post-mortem lividity. At the end of the course, you will find the project which we made downloadable, so you're able to review and process it later. Let's choose applicable scanning settings first. High-quality texture is very important in this case. Therefore, we will reduce the range to 0.8 meters to ensure that the texture resolution of our final model lives up to our expectations. We will switch on the distance scanning mode, as this allows us to always be aware of the distance between the body and the scanner. As you already know, it highly influences the level of texture detail. A bit later, we will also explain the process of photo texturing. But for the moment, let's take a look at how you can get a colored model using the texture from the scan data. On top of good texture resolution, we are also interested in a high level of geometry detail for the wound. Therefore, we are going to use HD mode. We start from the head and scan the left side of the body, making sure that we have enough overlap for the data of the right side. Not only do scanner settings matter for obtaining a good texture for the model, scanning technique does as well. Our scanning specialist tries to maintain a 90-degree angle whenever possible to achieve good results in terms of even texture distribution. Once scanning is finished, we export the project from Leo. As promised earlier, let's take a closer look at the raw data we can find in the workspace in Artec Studio upon project export. To put it simply, raw data is the high-quality scans that require the final touch. To turn them into actual HD data, you need to run HD reconstruction in Artec Studio. Until then, the scans are not shown. To perform HD reconstruction, you're required to state the frame frequency and point density in the Tools panel. You are already familiar with the concept of HD frame frequency. If you have set it lower than 1 on Leo, then you can leave it at 1 in Artec Studio. The point density shows how many more points an HD scan has in comparison with SD data. That is, an HD scan reconstructed with an 8x setting will have 8 times more points than its SD counterpart does. This greatly affects the ways that difficult-to-reach and hard-to-scan areas appear in 3D. Higher values will allow for more surfaces to be reconstructed at the edges and will sharpen the fine details even further. But the more points the scans have, the more RAM they need, and the more time that scan processing tools need to work with the data. A few things to note here. The point density does not affect the duration of HD reconstruction process. It is the same for every setting. Also, as long as you have raw data in your project, you can rerun HD reconstruction multiple times with different density settings. And finally, raw data takes space, about 2 to 5 megabytes per frame. So, once raw data stops being useful to you, it can be deleted manually to save space on your computer. We have used the 1/4 HD frame frequency for this scan, that is a value higher than the default. This will enable us to ensure good reconstruction of hard-to-reach areas, such as armpits and the areas between the fingers. At the same time, there are no particularly small details on the body we want to reconstruct. So, the default point density can be decreased. Instead of 8x, we will use 4 and still get a good result. Density is recommended to be left at default or increased if the body has a lot of fine geometry that needs to be documented as detailed as possible, or if there are some difficult-to-scan parts, for example thin objects like wires or knives, or translucent or glossy materials. Following HD reconstruction, we can see the scans in the workspace and 3D view window. If a scan is continued for several sessions, it will appear as a group in Artec Studio. Each time the Add Scan function is used on Leo, a new scan group will be formed. Scans need to be processed in order to build a model in Artec Studio. But before we start working with the data, it makes sense to check whether the scans are good or you need to rescan your object. Scans consist of frames. The usual frame is a single three-dimensional surface which contains information about the shape and features of the object's surface. The texture frames, marked respectively, are used for rendering the scans with texture and for applying texture to the model. The core frames are in bold font in the list and are used in case we want to render the geometry of the scan with a minimal number of frames. As it goes from the name, core frames, they form the skeleton of the scan as they are captured each time the scanner sees a new set of geometry in the field of view during scanning. As a smart way to manage system resources, Artec Studio does not show all the frames in the selected scans by default. The texture color mode shows only the texture frames of scans, and the scan color mode shows only core frames. In general, we recommend to use the scan color mode, as it shows more frames and gives a better overview of the frame registration, that is, their relative position in regards to each other. If you have any doubts about registration quality, turning Show All Frames will allow you to better see if any frames are out of place. Since rendering all frames all the time is cumbersome, don't forget to disable this setting afterward. Texture mode is mostly useful for aligning scans with no geometry and for looking at the registration of flat surfaces with rich texture. With any color mode, the back face can be left transparent by default or changed to black if it is better for the visibility of your scans. Scans can be processed with the help of Autopilot, a smart processing workflow, or manually. Let's talk about Autopilot first. It always strives for the best result and always automatically configures the best applicable settings for your scans depending on their quality. It is especially useful for users without a lot of scanning experience because all they need to do is to answer a few simple questions in order to achieve reliable results. However, a more experienced user is likely to get a more customized result using manual mode. First, you need to select the scans the Autopilot will be working with. The main purpose of this step is to deselect unwanted scans if there are any in the workspace. At the next step, you need to instruct the Autopilot about the quality of the object's features and surface. The top lines from scan quality to hole filling method inclusive request critical information for successful processing and must be filled in. If in doubt, feel free to use tooltips to provide correct information to Autopilot. Given the post-mortem lividity, we can define both scan quality texture and scan quality geometry as good. But in fact, a human body scan has sufficient geometry, so if you mark only scan quality geometry as good, processing of the scan will be done successfully and even faster. The object size is large. With this particular case, where the geometry of the wound is not that large and it was thoroughly scanned, the best hole filling setting will be by radius. With Auto setting, it will fill on scanned areas up to 5 mm in radius if there are any. The setting is generally good for scans where you might have slight blind spots that you don't want to show up as holes. If there is a deep laceration with much intricate geometry which cannot be scanned entirely, we recommend to set the hole filling to Don't Fill. This way there will be no artificially created geometry and the 3D shape of the areas you're able to scan will be genuine. Watertight means that all unscanned areas will be filled, and this is usually applicable when an object was scanned from all sides. It is not suitable for us here because if we choose it, the disconnected borders of the scan will be artificially prolonged and connected. All the other settings can be either set manually or you can set them to auto. Deselect the texture option if you do not need to apply color to your model. The next step, removal of unwanted surfaces and background, can be skipped if you don't have any unnecessary objects next to the one you're scanning, and that is exactly our case. A bit later, we are going to take a look at the manual processing, and then we will discuss in detail how to operate the Eraser tab if you need to delete something after all. If you have only one scan group in your Artec Studio workspace, you will need to take the next step called alignment. Your scans are already likely to be positioned properly in regards to each other. If you have more than one scan group, you need to align them together, as the correct relative position of different scans of the same object is a necessary condition for making a good 3D model. You can do it automatically by pressing the Auto Alignment button. If this works successfully, then you can proceed further. If some scans are misaligned, you can fix this in the manual mode. At least one group should be marked as registered, that is blue, if rendered in the scan color mode. The position of a registered group will be taken as default for the other one. You can change the status of the group, registered or unregistered, by making 2 fast clicks with the left mouse button on its name, or by clicking once with the right mouse button on its name, and then choosing the appropriate option in the drop-down menu. If scans are misaligned within a group, you can ungroup them and align them manually. Before we talk about how to align 2 scan groups, let's first talk about how to navigate them in the Align tab. To move both groups, hold down both mouse buttons. To move only the non-registered group, the one rendered in green in the scan color mode, press and hold down Shift and the left mouse button. To rotate the scene, hold down the left mouse button and make the rotating movement on the screen. And to zoom in or zoom out, hold down the right mouse button. When 2 groups are selected and at least one of them is registered, meaning it is rendered in blue, left-click on one of the groups to make an alignment point. Then left-click on the same spot on the scan from a second group. We recommend setting 3 point pairs for alignment to work, and please place them on different sides of the object. To move a point, click on it with the left mouse button and move it. To delete a point, click on it with the left mouse button and hit Delete on your keyboard. To delete a point pair, click on either of the points with the left mouse button and press Delete on your keyboard. When you have set the necessary number of alignment points, there are 2 ways of aligning. First, hit the Align button, and the algorithm will match the geometry of the scans, and the texture if you choose so. Given the size of the HD data, this process can take a while. A much faster way would be to click Align Markers. This way, the alignment will be instantaneous, but you will need to pay more attention when positioning your point pairs, and maybe add a couple more on top of the 3 pairs you've already made. When you have finished with alignment, click Apply. If there are holes or not enough overlap between the scans for manual alignment, exit from Autopilot and add a scan of the missing area. After this step, no manual actions are necessary, because all the algorithms will perform in a sequence. You can stop Autopilot at any step and undo any action. If you do not interrupt it and let it go, as soon as the model is ready, it will be rendered in the 3D view window. The texture of the model will be adjusted automatically. If necessary, you can right-click on the model in the workspace and select the Adjust Texture option to tweak the brightness, saturation, hue, gamma, and contrast of the texture. In this case, we have used the texture received from the scanner itself. In our next video, we are going to talk about photo texturing, when pictures from an external camera with a higher resolution can be used to apply color to the model. Once the model is ready, you can take some basic measurements in Artec Studio. Linear, from point to point. Geodesic, taking into account the curvatures of the body. And we can also build a plane and measure the perimeter of a limb or the torso. No matter how you created your model, via manual processing or with the help of Autopilot, you can upload it to the Artec Cloud account, which corresponds to the account currently logged into the Artec Installation Center. Here you can define the level of access to your model. It can be view-only or with the possibility to download it. In any case, all the people you have shared it with will be able to leave their comments in Cloud. Also, you can export a model from Artec Studio to save it as a file and use it further, for example in some third-party software. First, click next to the model's name to check it in the workspace. Then access the File menu and choose the Export Meshes command. Specify the destination folder, enter the file name, and select the appropriate format from the drop-down list. The most popular formats to save a model without texture are STL, and if you require a model with texture, OBJ format is likely to be your best choice. Here you can also specify the format in which the texture will be exported.